Whoa. So you found your way down the rabbit hole in the description again. How many? What does that mean? How many what? It's without context. 2 ears, 2 eyes, 1 nose, 2 little legs, 4 little feet, 1 little fluffy tail. How many requires context. How many's here? Well, that seems silly, doesn't it? Answer is obvious. 2. Okay, intuitively, there's 2, but really, the question's absurd. How many is here? Well, 2 sets of 1. There's also 4 sets of 2. There's 8 sets of 1. What else is there? 1 set of 8, 4 sets of 2, 2 sets of... Wait a minute. I don't even know. There's so many ways that we can interpret the question, how many, that it's meaningless without further specificity. Numbers are arbitrary designations. They are meaningless without us to apply some context for what the numbers are intending to discover. Consider the algebraic expression 3 times 4 equals 12. Well, if ever there were an arbitrary designation, that's it. 3 what times 4 what equal 12 what? Or 3 times 4, which we can assume are similar things, equal 12 what? Are they also similar things? Or are they identical? Well, typically integer values are assumed to be linear, so there's just no real dimensionality to them beyond that. 1. This is 1 over. This is 2 over. This is 3 over. So how can something that's one-dimensional multiplied by something else that's one-dimensional be two-dimensional? Ooh, that's a head-scratcher. 3 of these linear units times 4 of these linear units give us 12 of these two-dimensional units. My point isn't to really clarify anything for you, it's to further confuse you. It's to get you to question your assumptions about mathematics and labeling and designations, which are arbitrarily designed by us, and they suit our purposes. There is no meaning to those expressions beyond those meanings that we ascribe to them. Numbers are symbols. There is nothing empirically valid about numbers. In fact, we even have a preference for integer numbers that really can't be substantiated empirically. Consider the case of a cube, or a square that's 1 times 1, and then across its diagonal, the distance will be root 2. Root 2 is what we call irrational because there are no definitions for root 2 that can be made in terms of or with respect to 1 as a base. So we could also consider that 1 is irrational if our base were root 2, because there are no ways to express these side lengths of 1 in terms of root 2's. So you might see the fraction 3/4 and automatically assume that 3/4 implies a question. You might make the assumption that it's asking, what is 3 divided by 4? And so it's reasonable enough an assumption, and 3 divided by 4, if you actually type it out, is 0.75. And now you feel satisfied because you're seeing it in decimal form, and because you're a 10-fingered creature, you like decimal form, especially if you're European. Who said anything about 3/4 being a question? Maybe it's a statement. If it's not interrogative, it's declarative. Therefore, it could be saying that it's 3 sets of 1/4. Multiplication and division are identical. They're the same operation. So you can think of this as 3 over 1 times 1 over 4. Or you can also think of it as 1/4 times 3. It seems like, okay, it seems like I'm being ridiculous that it's silly that I should even be making a distinction, but this is the simplest possible example I can give for this. But in more complex problems, this minor alteration that you make to your perspective can mean all the difference in the world. It's the way that we view the problem which will result in a different answer for us. Why are division and multiplication the same operation? Because division is just multiplication by the reciprocal. 3 divided by 4 is the same as 3 times 1 over 4. Similarly, addition and subtraction are also identical operations, because subtraction is the same as the addition of a negative number. Your natural biases are likely suggesting to you that there's a missing piece here. But that is entirely a construction of your own doing. There's no missing piece here. This is a declaration in and of itself. That stands. Those stand. They are there. They're very real. And there's nothing taken away from them simply by the omission of what you infer belongs there. Don't ascribe your own personal biases to the world. Take the world as it is. Now, of course, I won't be sending you on your way without a math problem to consider. How about this one? You have a sheet of plywood. It's 4 by 8. What are the 3 maximum circles that you could cut out of this 4 by 8 sheet of plywood? And let's assume that your blade doesn't have any width at all. You have an imaginary scalpel laser that leaves no waste. What would the diameter of your circles be? No approximations. I want the answer in exact terms. That's what a good math student gives as an answer. I believe it was David Hume who, this is popularly attributed to him, the logical fallacy that is, you can't derive an ought from an is. In other words, value judgments shouldn't be made from factual pieces of information. So what's implied by this is that it's difficult to derive a morality, like a science of ethics, from empirical discovery. Science, in other words. Sam Harris argued in The Moral Landscape that one can derive morality from a collection of facts. And it's a very good argument, and I would invite you to go investigate it. Hey, thanks for listening to me ramble about things I hope you don't think they're meaningless. See ya.